Hi ladies and gentlemen, welcome to Scale Lesson 6-6. We're going to be talking about scale drawing versus scale model and how to determine the relationship between a model and either the plan that's drawn or the one that's built. So make sure that you're taking notes, you're taking and copying examples, and it's not too terribly long of a video, but there are a few examples to make sure you're getting as well as some definitions. So at this point, make sure you copy down definitions. And we're going to be talking about scale drawing. And when we talk scale drawing, we're talking a two-dimensional drawing that is similar to the object it represents. When we talk about a scale model, we're talking a three-dimensional object or model that is similar to the object it represents. Scale gives the relationship between either the drawing or the model and its actual item, actual dimensions. So please make sure you're pausing if you need to at this moment to get these definitions down. I'm going to clear the page of all my markings and then go ahead and unpause when you're ready for the next slide. Okay, so ladies and gentlemen, we're talking about scale drawing. Remember that's the 2D and kind of almost showed my D there, right? Mirror 2. So if we're looking at a map and the distance on the map has two cities that is 3 inches apart, we want to know what the actual distance in miles in real life would be between these two cities. We know the map scale is 1 inch to 25 miles. Well, the one thing I want to do is go ahead and set up in Words how I want to handle that. Let me see if I can make that a little bit better. Circle. There we go. So inch to mile is how I'm going to be setting up my ratios. It's saying let x represent the distance in miles that we don't know, which I'm sure most of you would have done at this point. So if you want to take a moment after and read how it tells you to set it up, that's fine. But we're going to set up inch to mile, and if I know that my drawing has 3 inches, and I know that my actual is going to be for every 1 inch on the map, that it's going to be a real 125 miles, then I need to just find this right here. I need to find the actual miles for the 3 inches. So at this point, I can easily cross multiply and have 3 times 125 would be 375. And 1 times x is going to give me 1x, so it's just plain x. So 375 miles equals the distance in real life. Now, if I didn't see that this was an easy way of finding it, I could see how did I go from 1 to 3? I must have multiplied by 3, or 3 to 1, you divide it by 3. And how do I get there? So 125 again times 3. There's multiple ways, but this here is my answer. 375. Let me try to write this. I will get better at this as time goes, I'm sure. So 375 miles is what x is in real life. Go ahead and pause as you need to copy any of this down. I'm going to go ahead and clear the screen, and then I'm going to move to the next slide. Okay, so ladies and gentlemen, we're talking about finding the skill of a drawing still. Sorry, I was thinking we were moving on to the model already. So in architecture, a skill drawing. In a skill drawing, a wall is about 2 inches long. The actual wall is 12 feet. Find the scale of the drawing. So if we know in real life, and we know in the drawing, R is for real, D is for drawing, that I have for 2 inches in my drawing, that I have 12 feet. Again, I should have actually set this up so that in my drawing would be over my real, because we always talk about the model or the drawing compared to the real life scenario. So I am sorry that I actually did that. So bad. For those of you who are copying that down, just put a little line through it. So writing a ratio using corresponding side lengths of the scale drawing and the actual wall, then simplify the ratio so that the numerator is 1. So in this case, oh, I gave you the answer is 1. I want to find out for every 1 inch, how many feet is that going to actually represent? So if I have 1 inch I'm saying this ratio. So how do I go from 2 to 1? I divide it by 2, right? So 12 divided by 2, 6. So 6 feet technically. So I could say my ratio is 1, and I'm going to put those little dashes that mean inches, 2, 6, and I'm going to put the dash that means feet because I'm just having a little trouble still learning with my pen. So that it's for every 1 inch on this drawing, it represents 6 feet in real life. So go ahead and pause and take down any of the notes that you feel that you needed. And let's go ahead and move to the next slide when you're ready. I put continuing to play. Okay, so ladies and gentlemen, here's the slide I thought I was at a second ago. Finding the dimensions of a scale model. What we need to do is we need to think about the proportions. One little side note is if the measurements are the same, we can get away without writing the actual measurements. So if I'm talking centimeters to meters, I've got to clarify that. I need to know that. But if I wanted to do centimeters to centimeters, oh my goodness, that is having so many troubles, don't I? Then I can get away with writing it just like that. For every 1 centimeter, I get 200 centimeters. I don't have to clarify it if it's the same. If it's different, I must tell. So a model of the Sears Tower in Chicago has a scale of 1 to 103. The height of the Sears Tower's observation deck is 412 meters. Find the height of the observation deck in the model. Now they've used words for us, the model over the actual Sears Tower. So if the, sorry, for every 1 inch it's 103 inches. So I'm going to put 1 inch. I'm sorry, did it say inches? No, it said meters, and I just converted the metric to the United States and totally did it wrong. So for every 1 meter, I'm going to have 103 real meters for the Sears Tower. So model over the actual. Now over here, it tells me in real life that the Sears Tower observation deck is 412. So I need to know, what does that look like in the model? So I can cross multiply and I can say 103, that is a 3, x, because I'm cross multiplying these two things right here, equals 412. I need to divide both sides by this 103. When I do that, I find out that x equals 5. I'm sorry, 4. So when I'm dividing each side, I was dividing it by 103. And I know that the model observation deck is going to be 4 meters. This was actually your last slide, so please go back through all of these and see how the scale drawings and scale models are really very similar to all the other proportions we have done. Um, Again, make sure you know the learning target, and have any questions, make sure you're prepared to come to class with them. Thank you.